Thanks a lot. Yeah. How many of you have used isolates? Oh, pretty good. How many used it by calling compute? And okay, so quite a lot of did it already really manually setting up an isolate and do all the stuff yourself. Why are you here? Okay. Yes, some notes. I won't go into the details how you calculate a Mandelbrot set image here, because I don't understand the math personally completely. So, but I took it as a nice example to show what isolates can do. It's and the other thing that's important is that the code is not optimized for maximum performance. There was one really nice demo using the GPU that does the same thing in real time, yeah, recently on Twitter. But it should show you the difference if you run in one isolate or multiple isolates. Yeah, single threading. Actually, most of the time, this is one of the things that so often is reported wrongly. They say, okay, Dart is single threaded. It's not. Dart always runs in a single thread, but you can have multiple threads, multiple isolates that allow you to have multiple codes run in parallel. The difference between multi-threading and real parallel processing is that we really move from that the operating system just simulates that we have code parts that are executed in parallel to really using multiple cores at the same time. Yeah, and this is really important today because we have CPUs with more and more cores, and at the same time, physics limits the absolutely clock frequency of CPUs. So if we have really calculation-intensive work, it's good to leverage all existing cores. Yeah, I try to make this a little bit visible here to see. Normally, if you don't use isolates, everything will run on one core. And our idea or our goal now will be, how can we split the work on several cores? And yeah, normally I would switch now to the demo. We will make the demo a little bit later. Huh? Yeah, why should we do multi-threading? Besides of the performance gains, if you have multiple cores, often your code gets easier to understand. At least if you try to implement parallel processes without threads or isolates, you have to resort to write a state machine. And state machines can be pretty difficult to understand and to read and to write. So this was one of the main reasons why programming languages and operating systems started to introduce threads and multi-threading. The problem often is, at least in most other languages in the past, that there you just call some function, create thread, hand over a function, and this function will from there on run really in parallel to the rest of your code. And you can imagine what problems you can have if both parts try to access the same variable at the same time. Yeah, so you can get data corruption by this, or and to avoid data corruption, you typically have synchronization mechanisms like mutexes or semaphores, so that you can make one thread wait on another thread before it continues, which works, It's fine, but the problem is you can create deadlocks, so that that two threads start waiting on each other. Yeah, so it's also not the best solution. That's the reason why Dart chose a different way. They decided to go to isolates, which are also threads that or functions that are executed in parallel. But the important thing is no isolate can access the data of the other isolate. Yeah, and now on the first look, see, okay, what's this? How does it work? What is the sense in this if we can't access the other isolate? But what we can do, we can send messages from one isolate to the other. And by this, we are always secure because the data that we transfer is copied. So if we send data from one isolate to the other, a copy is made, and you're never are in danger that you get a data corruption by this. So even if one isolate crash, it won't bring your whole app down. You can register error handlers that will get notified if your isolate crash. So you can even restart an isolate if you need to. And the way you communicate is by send and receive ports. Actually, a design decision that I'm not so happy with. I would have preferred if the Dart team would have used just standard streams, because why introduce something new? But now we have send and receive ports that are tied, it's always a pair, or send and receive port. They are coupled, but you use them like a standard stream. You listen to them, you write to the send port, and you listen to the receive port. So it's not really a big deal. The nice thing is that most objects you don't have to care about how they are transferred, because Dart does this completely under the hood. Even if it's a complex nested object structure, it will be deeply copied and transferred to the other isolate. The only thing that where you run into some limitations is, for example, the typical example is an HTTP client. You can't pass this one over an isolate when because it's sort of a live object that has has connections to the underlying operating system. So if you need an HTTP client, what you have to do is you have to initialize an HTTP client in each isolate again, your own HTTP client. But then you also can use it. You can use it from there. Yeah. So it's no problem to do HTTP calls out of an isolate and just return the result to the app. The whole thing, yeah, it feels a little bit cumbersome at the beginning when the setup of an isolate. You will see in a moment. And what's important is that creating an isolate takes a little bit of time. So if you need the isolate repeatedly, it's recommended that you don't call compute every time, because if you call compute, a new isolate will create it every time and will be destroyed at the end. And that you keep your own pool of isolates and manage them yourself, then you don't have this problem. Yeah, there's some. Yeah, I know I have a lot of text on the slides, but it's just a lot of topics. Yeah, one of the things that people are sometimes surprised is if you have global variables, they just appear as a copy in the isolate code. So, but if you access one of them in the main isolate, the copy in the in your child isolate won't be affected if you write to a static variable or a global variable in one isolate. If you use getIt, this is what you have to register your objects in the isolate again, because it's also a global variable at its base. So That's important to know. Yeah, you can pause, kill, and resume an isolate from the outside. This can be helpful. And yeah, when you create an isolate, you have a one-time chance to pass an object to the newly created isolate. And that's the point where you can pass initialization data from your main isolate to your child isolates. We will see this in a moment. Oh yeah, the ports, if you pass messages back and forth, they are not type safe. So if you decide to pass more than one object type over one port, make sure to check with is before you cast it, that you get the right object. And the last thing is, I said before that messages are always copied. This is definitely a problem if I have a large chunk of data that I want to transfer. For this, the Dart team introduced the transferable data type class, which actually circumvents the limitation. It works by the way that if you send data, transferable data type to a send port in an isolate, it's not copied, but the rule is you are not allowed to access this data after you have sent it. It's no longer accessible for your isolate. And in the receiving isolate, you will get the data without copy, so it's very fast. Yeah, we use this in a moment. Yep. Actually, there's certain steps that you have to do when you create isolates. The first thing is you have to create a receive port that you are able to receive future messages from your newly created isolate. Then you pack all your initialization data and the send port that is connected to this receive port into an object and pass it via isolate spawn to the newly created isolate. And then you wait for the first message that you get from the isolate, and from there on you can start controlling the isolate over the port. Yeah, and in the newly created isolate, you have to do some additional steps. You have to cast your initial data structure to your that you get your data. You create a receive port local to the isolate and pass the send port of this receive port over to the main isolate via the send port that you got from the main isolate. It's a little bit confusing at the beginning, but you have to establish a two-way communication. So this is the goal of our app. We want to calculate Mandelbrot sets. We can zoom in here, and you see it's not it takes a little bit. It's a little bit sluggish, yeah. And because currently we don't use any isolate. So the main isolate does the calculation for every pixel here. Now, if I increase the number of isolates, you see in if you do render time, yeah, it already got down. Now probably this baby has 8 cores. So let's see how we got there. And you see how the render time goes down, yeah? It's much faster. If you go too much up, so now we are probably above the number of cores of this this computer. Still okay. Oh, that's pretty well. Yeah, no, but it gets worse again. Yeah, we are now at 200 milliseconds. So the 8 is probably a good choice. Yeah, versus And that's the amazing thing of, if you never have been in a Mandelbrot set, you can zoom in as much as you want, and you get always amazing structures. Yeah, this is okay. How do we do this? We have to manage all the isolates. I created a class isolate entry, and this has a creation function, a static creation function. Interesting. It just switched on my on the computer here. A static creation function, which basically just does the spawn and passes. Yeah, I have an initial data structure where I have all the data. The receive port and what I else need to initialize. I pass this to the spawn. So this is executed in the main isolate. And after the spawn, I directly wait for the first message to be returned. And then I return the newly created isolate entry for that I can after that I can access it again. Then we have the actually isolate handler, which is also a static function of the of this class, and this is the part that is initialized immediately after you call spawn. Yeah, so you see we create a receive port, and we store the isolate ID that we get in the init data, because the problem is later on we won't know which isolate sends us the resulting data. Yeah, so we have to keep track by storing inside the isolate which isolate it is itself. Yeah, so we store this. Then and after we send back the send port that we have the communication in both directions, and we start to listen on the port that we got from the main isolate. Yeah, and we listen for tile request messages. We split this the Mandelbrot set into multiple tiles, and when we got a tile request message, we will render the data to it. Yeah, so we create an image buffer, which is just an uint32 list, and pass this to the render function, which will do the rendering for this tile. Yeah, and after that, we send the data to the result port, a tile response object, which also it has the isolate ID, important, the request ID, that we know again which request was it that that this is the result to, because the reply from one isolate will come to later, sometimes later. So I don't know from the beginning which request is it. So I need to have a request ID. And yeah, the width and height of the object, and then is what I said before. The data we use in transferable data type data from list with the image buffer. So that's the way how we pass the data back. Yeah. Now, we don't know how fast one isolate is, because we don't know how many other tasks are on this core, for example. So we have no idea which isolate will be ready first if I start to split the load onto several isolates. So for that, we have to organize this somehow. We have a class called render manager here, which is, if you look at the source code, very simple in this case, that I just use a global variable to access it, and no state management solution or something like this to keep it really simple. And this has a render tile function that returns a future of an image. Yeah. So actually, what the what the main widget does that is for every tile, it will call this render tile function with the coordinates, and render tile expects the future, returns the future, and on the other side you see the part in the tile widget that we have the render Mandel function. This is called in the init state of the tile, and you see it's an then I wait for the future result, and when it's there, I just do a set state with the new image. Yeah, so it's very basic. Yeah, to display the resulting image. So keeping track. Now it gets interesting. To keep track of everything, we use several lists and one map. So one is I have an isolate list to keep an access to all my isolates that I have created. I have a second list available isolates where I put all the isolate entries of isolates that are currently not busy. Okay, yeah, give it a try. Yeah, and waiting tiles we will see in a moment, and we have a map of completers, and that's an important point because the thing is, how do we manage it to that our UI directly gets back a future that it can work with, and we can later on pass the data. And for this, we use this map of completers. What we have in the now we have a little bit more detail of the render tile function that we see, okay, if we get a new request, yeah, that then calls the render tile. No, if the tile widget calls render tile, yeah. So what it does, it checks first if the isolate list that we have something, okay, and then it creates a tile request, which contains the request count. This is just an idea that I continue with each request. I just increment it, and the width, the height, and upper left coordinate. That's the coordinate in the mathematical space of the Mandelbrot set, and not on the screen space. So what then happens is we check if available isolates is not empty. If we have an isolate, we remove it from available isolates, and we send the tile request to this isolate that we just got from out of the list, and we hand back directly a future of a completer, and we store the completer in this map, which is the tile request ID plus the completer. So that when the isolate gets finished with the computation, we can directly access the completer again and complete and transfer the data to the UI. Yeah, this happens with the next entry, exactly the same. So we fill up the requested tiles completer map, and the isolates are busy computing. So now we get in the situation we don't have any isolate left, and what do we do now? In this case, we start filling up the waiting tile list with tile requests, and also for every waiting tile, we just add another completer. Yeah, so it's that we don't this part doesn't change in any way. We always return the future of the completer, and we fill up the waiting tile. So now let's see. This here is the part of the render manager, the tile result port, where we listen for finished messages from the isolates. And that's actually an important thing. Multiple isolates can share one port. Multiple isolates can send to the same port. So I use here one result port only, and all isolates directly sent there. And what you see here in the upper part, this the second part here, it's actually an insane amount of code that you need if you want to create a bitmap from a simple integer list, yeah, which is a little bit stupid because the data is already in the right format that we could directly use it as a bitmap, but Flutter is in this way, or that Dart UI is a little bit complicated how to do it. And after we've done this, we go into the requested tile completers list, because we got in the message the correct ID, so we can now complete with the data, and we remove it from the map. And now it's the important thing is we check at the next step. In case waiting tile is not empty, we directly pass the next waiting tile request to the isolate that just got finished with the last job. Yeah. Oh, does it work?
In the middle one.
The middle one. Okay. Yeah. Now, in the other case, that we have no waiting tiles here, then we do the same here, but then in this case we add the isolate that just got ready back to the list of available isolates. Yeah. So that's the idea how it works. And by this, it always either it executes the waiting tiles, or it waits for the next one that comes in. Yeah, so it's pretty straightforward. Yeah. Let's yeah, one there's I don't know, should we questions directly now, or
just do your conclusion and we will ask.
Okay. Okay. Before we go to the questions, I have one last slide that I just want to share with you. I don't know if you may know that last year I created a charity organization together with some African developers, Help Devs, and we shipped about 60 laptops to Africa a lot to aspiring Flutter developers. And I only can recommend follow the on Twitter Help Devs what we are doing, and if one of you wants to directly help us, I'm always happy to get some PayPal donation for the project. It definitely goes to the right people. You see this. It's so great if you get pictures like this back, and you see how happy the people are. Those things. Okay.